Hello, scientists. Welcome back for another day of Read Aloud. Today, we will continue to examine the complex science concept of how plants and animals adapt to survive in their environments. As we have read our other texts, we have seen that to effectively read a scientific text for understanding, it is important to stop and utilize the various visual supports provided in the text, such as photographs, illustrations, and diagrams. If a visual includes a caption or label, we should reread that information as well as the accompanying information on the page to see how they fit together. Visual representations provide essential information that helps us better understand complex science texts. They give support to help us clarify new, difficult ideas or concepts, complicated sentence structures, or unfamiliar technical terms. Visual representations can even help us make connections between concepts that don't seem naturally connected. Today, scientists, we're going to continue to explore what Bobby Kalman has to say about animal adaptations in The Science of Living Things. How do animals adapt? As we pause during our reading to carefully examine scientific illustrations, photographs, and diagrams, we will enhance our understanding of the author's key points. So we'll take a little photo walk through some of our previous reading, and today we are going to be starting on page 12. Staying warm. Some animals have adapted to living in cold places all year. They neither migrate nor hibernate. Instead, their bodies and behaviors have changed to help them keep warm in cold temperatures. Blubber for warmth. Seals, whales, and walruses all live in cold water habitats. They have a thick layer of blubber or fat under their skin that helps keep their body warm. The blubber insulates the body and keeps the cold out. The Arctic tundra. Animals that live on the Arctic tundra must find ways to keep warm. The tundra is a cold desert and its soil is always frozen. Animals such as musk oxen have a thick fur coat to protect them from the freezing temperatures. Arctic foxes and other small animals dig holes in the snow. The snow traps the heat from their body inside the hole and helps them stay warm. What tiny ears you have! Animals lose much of their body heat through their ears. The Arctic fox has tiny ears compared to those of its cousin, the red fox. The Arctic fox's smaller ears help it keep more heat in its body. So let's look at pages 12 and 13 together. I noticed that these pages have 3 beautiful photographs as well as detailed illustrations with accompanying captions. They help us understand the key idea of how different animals stay warm in cold weather. And we read in the first section that some animals have blubber. This photo of the walrus might help me understand how blubber helps it survive. The blubber of a walrus can be 6 inches thick. It keeps the animal warm in the coldest weather. Wow, that's like half of your ruler. 6 inches of blubber, that is a lot of fat. After we read the caption and look at the photo, it's helpful to return to the text and reread the information to put the 2 ideas together. So let's reread that paragraph, blubber for warmth. Seals, whales, and walruses all live in cold water habitats. They have a thick layer of blubber or fat under their skin that helps keep their body warm. The blubber insulates the body and keeps the cold out. The blubber insulates the body and keeps the cold out. So the blubber is like a huge layer of blankets that doesn't allow the cold to get to the body. But I wonder if a polar bear has blubber. Because there is a picture of the polar bear there. So let's take a look at the caption. So what's interesting is the caption is all the way down at the bottom, but it does tell me it's referring to the top photo. So we need to make sure we really take in all of that information on the page. A polar bear's fur coat is made up of hollow hairs. Heat from the sun travels through the hairs and into the bear's body. The bear's skin is black to help absorb heat. So this photo helps me to understand how the polar bear's fur helps it stay warm. Okay. So I'm going to reread staying warm again one more time just to make sure I'm really understanding what I'm seeing. Some animals have adapted to living in cold places all year. They neither migrate nor hibernate, so they don't leave the cold places. Instead, their bodies and behaviors have changed to help them keep warm in cold temperatures. Okay, and if I go back to my caption, the polar bear does that because heat from the sun can travel through his hollow hairs and into his body. And his black fur can help him absorb heat. So understanding how the polar bear's fur works and how it's hollow really helped me to understand the key idea that fur is an important adaptation for surviving the cold. I wonder what this illustrative diagram of the two foxes is about. So let's take a look at the labels and the captions. The one on the left is labeled red fox, and the one on the right is labeled Arctic fox. The red fox lives in areas with hot summers and cold winters. It needs larger ears to release body heat in summer, whereas the Arctic fox needs to hold in heat most of the year. So this information really helps me understand how the bigger ears would let out the fox's body heat. Seeing the Arctic fox's smaller ears helps me understand how different they are and how they help the fox keep the heat in. The illustration and captions support our understanding of a complex topic, understanding how animals in the same species adapt to their different environments. The illustration helps us visualize an important difference in the structural features of red foxes versus Arctic foxes to compare and contrast how the adaptations work for each type of fox. Take a second and think, how else do the images on these two pages enhance your understanding? All right, let's move on. So these pages that we're going to take a look at now, pages 14, 15, and 16, are going to show us some complex ideas about how animals keep cool in extremely hot weather and how others adapt to life in the darkness. Keeping cool. Deserts are places that receive very little precipitation or rainfall. Few plants grow in deserts because of the hot, dry conditions. Animals in these areas have adapted ways of finding food, storing water, and keeping cool. Animals that live in dry habitats get most of the water they need from the food they eat, such as seeds, succulent plants, and insects. And I do notice that precipitation and succulent are bold words. They're probably pretty important vocabulary words. Some have unusual ways of taking a drink. The darkling beetle drinks water droplets that have formed on its body from the morning dew. And then if I look to the left, I can see that image of the dew droplets, and the caption lets me know that the darkling beetle tilts its body forward and allows the dew droplets on its back to fall into its mouth. Pretty cool. Storing water. Deserts do not have ponds or rivers from which animals can drink. In order to survive, desert animals must store as much moisture as possible in their bodies. Nearly all animals release water in their urine, but kangaroo rats have urine that is so dry it is a powder instead of a liquid. Adapted sleeping habits. Many desert animals hide from the sun during the day. They sleep in a burrow or underground home in order to stay cool. Desert animals that do not rest in burrows have a low body temperature at night when it is cool. During the day, their temperature rises slowly. It takes a long time for their bodies to warm up again, so they stay cool during most of the hot day. Hibernating in the heat. Many deserts are too hot and dry in the summer for some desert animals. Tortoises and toads dig burrows and estivate during the hottest, driest months. Estivation is similar to hibernation, but estivating animals go into a deep sleep to escape hot rather than cold conditions. Some animals can estivate up to a year while waiting for rain. So then I noticed this picture over here, and it tells me the jerboa digs a burrow in which it estivates during the 5 hottest months of the year. So I can see like it dug down and then it dug down deeper to make a little burrow. And this illustration of this animal in her hole really helps me understand this concept of estivation, which is similar to hibernation. I want you to take a second and either whisper to yourself or a partner, what are some of the major differences between hibernation and estivation? All right, moving on, friends. Like we said, we were next going to look at adapting to the dark. So many animals live in habitats that have little light. Some live in underground caves or in the deep sea. Other animals are nocturnal, which means they sleep during the day and are awake at night. Animals that hunt and move in the dark are well adapted to living in their low-light environment. Echolocation. Most species of bats are nocturnal. They do not need good eyesight to find prey or the animals that they eat. Instead, bats find their way in the dark using echolocation. They make high-pitched sounds that travel long distances through the air. When these sounds hit an object in the bat's path, they echo or bounce back. The bat listens to the echo and can tell by the sound whether the object ahead is a tree, rock, or another animal. Let's take a look at these illustrations and captions. So on the left-hand side, we see 2 illustrations of cats. The opening in the center of an eye is called the pupil. It controls how much light enters the eye. In bright light, the pupil closes to a narrow opening, preventing animals from being blinded. And in dim light, it opens wide, helping an animal see better. And down on the bottom, we see another drawing, and it tells us that horseshoe bats use echolocation to hunt insects such as moths. So these illustrations help us understand nocturnal life and echolocation. I see here the difference in the cat's eyes in the daylight versus in the night. In the darkness, the pupil is so much larger. In this graphic about echolocation, the blue arcs represent the high-pitched sounds coming from the bat. The pink arcs and arrows represent the echo or bouncing back of the sound, which allows an object to be located and identified. It can be very challenging to understand the complex science concepts in our text. To help us, it is essential that we slow down, study the visual representations, reread the text, and connect the text to the images. This will allow us to truly understand important concepts about plant and animal adaptations. And scientists and researchers, you can apply this to any sort of informational text reading that you do. Make sure that you are paying attention to all the information on the page.